Hello everyone, it's the Slimy Dog here with another episode of, well, not another episode. This is I guess a sequel maybe to the whole Pokemon AP calculus something blah blah blah. And I'm obviously done with my APs, right? So I'm not going to be doing any more of that. However, I do have to apply to jobs, and when you apply to jobs, you got to take interviews, solving questions like this one. So this is going to be hopefully a pretty straightforward question. I think I've done stuff like this before, so this seems like a pretty standard dynamic programming problem. So without further ado, let's get right into it. So what I like to do is always create a recursive version. This is going to take the parameters, which are kind of the states of the current problem. For something that I said was very standard, this is taking me a lot longer than I expected. We got our memo set. So this is our initial condition. And that's basically how memoization works. If we've not calculated it, calculate it. And if we have calculated it, just return the value. So now what is the logic? So we're going to loop through all of the possible values. So it's either the max of the current length or the length of I plus 1. Now we also have to keep a condition on this. So we only do this since we only want longest continuous increasing subsequences. We only do this if we have, if it's increasing, we want the previous number to be lesser than. And the last thing that we just need to do is, I made a huge mistake. So the huge mistake is over here. We're not doing any recursion, so that's what we're going to do real quick. So we should get the value of length at every position, and we're just going to find the max of that. So max is 0, and then return max. So this looks like this should work. First time, let's give it a shot. Let's see how this works. And if it doesn't, if it compiles, that's a good sign. That's not a good sign. Oh. Alright. So TIL, I can't do that. That's a much better answer. Still not the correct answer. And the reason for that is because, oh, this is continuous increasing subsequences. This is awkward. I was wondering, because the time complexity of that is n squared, and n squared is nowhere. It's not possible to do 10,000 squared in a reasonable amount of time. And this is the problem that I'm looking for. So let's just copy that code over real quick. And it's still wrong. Huh. I think instead of that, I'll do this so we don't accidentally recompute it. Whoops. And then, now this should work. Perfect. Submit that solution. Okay. So there's another problem. You know, I can't just do this, but fortunately for me, it's a pretty simple problem. I just have to do this. Yeah. I don't need to change that because this part over here is already going to be computed when I run this function, assuming that ternary operators are computed like in order. If it's not, then I'll just give up with C++ because it's not worth the effort. Not even going to try running the code. It's just submit it. I know this is going to work. Yep. So now let's do the relatively easier problem. This is easy. This is medium of continuous increasing subsequence, and this is something that I haven't really done before, but you know, it's supposed to be pretty easy. First thing that I would start off with is kind of a counter. Maybe let's actually start off with a for loop. So now we're going to loop through every single number, and we want to keep track of what the current number in the iteration is and the length of the iteration. So that's the length, and the current number is something we really don't need to keep track of, because you know, it's already in the array. and we're keeping track of the index in the array. We do need to keep track of the maximum length, however, and let's start at 1 so we don't have any index or out of bounds errors. So if nums of I minus 1 is less than nums of I, so we can just increment lengths. We don't have to worry about setting max length until the end. So we need to do it once here. We also have to do the exact same thing once inside, and I know code repetition is not good, but bear with. So else we just deal with that. Set length to 0, set length to 1. I think length over here should be 1 as well because we are including the first character. Then here we just return max length, and that should be good to go. So let's try this out. Oop, this is always so intense. There we go. Got the right answer. Yeah, I don't doubt this code is right, just because it keeps track of everything that it really needs to, and I don't see any pitfalls. I caught this pretty early on, keeping track of the max length and then resetting the length. So, I mean, from what I can tell, this should be right, so I'm just gonna submit it. There we go. For empty arrays, we want 0. Typical. They always have some strange requirements, which in the end makes sense, but these are edge cases that typically don't require any major code changes, so I can add that in really quickly and get that to work, and hopefully, there we go, this works. I'm gonna do a bunch of easy problems to start off. 2sum. 2sum's a great problem. So, how do we solve this? 2sum, given an array of integers. I think one way of solving this would be, just go through every single pair. That's really easy. So the easy thing would just be, I know I made a mistake here. There we go. Return vector int. Otherwise, return an empty vector. Moment of truth, and I got 2, 1. It's supposed to be in increasing order, so we always know j is going to be less than I. That's a fact mathematically proven by law, by the laws of mathematics. Submit this. If it works, it works. If it doesn't, it works. So we don't need the more efficient solution. That's a shame because I figured you could use well, there are 2 things you can use. You can use hash tables or dictionaries for the Pythoners here, and you could also do some sorting, and after the sorting, kind of go from the 2 ends and work your way inwards until you find the solution. So 2 interesting solutions to that. Add 2 numbers. Ooh, that's a tough one. I don't want to do adding 2 numbers. Palindrome number. Palindrome number. You look like a good one. Determine whether a string is a palindrome. The problem with something like this is actually no. This is actually perfectly fine. I was worried about integer overflow. So what I'm planning on doing is trying to reverse the entire integer first and then just do basic equality check. The problem with that is you might end up with some integer overflow problems, but I don't think that we'll have those. We're gonna get false if that happens, which is also good because, the answer is supposed to be false. We don't need a for loop here because we don't have a determined end. Whoops, sorry. Okay, perfect. If we run that, boom. That's supposed to be false, we got false. So the thing that these guys like doing is running it through a lot of edge cases, and I already got them. I already know what they're gonna do, so let's run through all of those, and if we get false on all of them, I'm gonna be pretty happy. Alright, and then let's run it on an actual palindrome just to make sure that it's working. So get rid of all of that. 4 7 4 1 2, and just to make sure it works on odd palindromes as well, we're gonna add one of those. So hopefully I get false, false, false. Ugh. So it's a good thing I did those checks. Let's see where we're going wrong. Of course, we divided by 10, but we're not multiplying and by 10. So we want to do that at the start, so we don't end up with something that's 10 times greater than we want. If it's negative, I think we just set it to false. That's how it's looking, which, you know, sort of makes sense. If something's negative, it's not possible to be a palindrome by a matter of law. And hopefully this is accepted. Usually when you have pending, it's not a good sign, but this is great. Palindrome linked list. Linked lists are a fun data structure. So anyways, that's the solution that I'm pretty satisfied with. If you got problems with that, take it up with probably just with me, you know, leave a comment down below. I don't know. But that's it with this episode. Hope you enjoyed it, and until next time, this is the Slimy Dog signing off, and until next time, I'll see, yeah, this entire video is bullshit.